You're good? Yeah. Okay, all right. Good afternoon. Larger crowd than what I expected. There was just me and Ian at one point. Yeah. But thank you for taking time to hear my little talk, right? Basically, what I'm going to do is give you a very high-level overview of the Azure machine learning platform, right? And I'll be talking mainly from the perspective of action recognition through sensor data, because that's something I've done before, and that's the demo that I'm going to do. And I'm also going to talk about this from the perspective of a prospective grant owner or grant applicant, how this might be helpful to you, and also for the perspective of the student, how this might help you accelerate your journey of learning how to do machine learning. All right. So what is AML, right? So this is the marketing blurb from Microsoft. That's why it's very wordy. Yeah. So it's cloud-based, right? Everything goes through the internet, and it tries to deliver on this promise of being able to quickly and rapidly deploy predictive models as an analytics solution, right? It helps you do machine learning very quickly. Now, it doesn't just provide the tool sets, meaning it doesn't just provide the data preparation, pre-processing tools and algorithms and all that, but it's a bit more end-to-end in the sense that you can package your model as a ready-to-consume web service, yeah, which I think would be of interest to many of us. Many times we do experiments and all that, right? But when it comes to deployment and putting this into production, we hit a brick wall. Yeah, but with this, you can deploy it as a web service. You don't have to figure out how to do this on your own. And then, in terms of your production setting or in terms of integration into existing systems, all you need to do is to know how to consume the web service. All right, and everything about this is very, very easy. It's done at a click of a button. Right? I didn't have to write a single line of code for this. Yeah, it's that simple. Okay, and yeah, and of course, all the other advantages of a cloud platform. No need to buy any more machines. As a researcher, as a grant applicant, we could move the money that we need for all this. Now, if you don't have enough for your machines and all that, you can go and put this under services or rental, I think. And I think you get away with it. Yeah, this is being recorded. No way. Okay, this is the basic workflow, right? So your data will live on the cloud. Right? So you need to physically upload your data. Right? You're paranoid, you can, I don't think there's much you can do about it. Right? So whatever data you upload will be sitting on your infra. Right? I don't think there's any encryption ability. They do not help you encrypt or decrypt your data once it's on the cloud. So up it goes, or you can park it on any one of the other related Microsoft storage offerings, particularly if you're dealing with larger size storage. Right? 10 gigabytes seems to be the magic number that they are looking at. Anything beyond 10, you need to put it somewhere else. Yeah, you cannot easily upload it into your workspace, because your workspace is only worth 10 gigabytes of storage for the free edition anyway. Once you've done that, right, then you have an online Microsoft Learning Studio web application. This is where you do all your drag and drop magic. All right, so no client on your machine. As long as you have internet connection, this is good to go. And then, once you've done your model, you have trained it, you have published it and all that, you've scored it and you're happy that it does the job, you can then expose it to other people as a web service, which I think is a major differentiator between offerings such as WEKA or KNAME or RAPIDMINER, whereby those are great for experiments, but you're going to integrate it, you need to monkey around the code a bit more. Now wrap it in Java or do something about it, right? But here, that's taken care by the platform itself, right? Once the web service is up, then you can consume it on your favorite programming language or favorite platform, whatever. So, magic question. How much is this going to cost me, right? I assume that most of the FYP students don't have a credit card. Right? Or maybe your father subbed you one, I don't know, right? Anyway, the good news is, unlike Amazon's offering, at that point of time, I'm pretty sure you need a credit card somewhere along the line. This is completely free. No need for you to sign up any financial credential. Sign up, and you provide you with this. However, there are constraints. It's too blurred on the screen here. What are the constraints? Right, as I've mentioned, your experiment can only run for 1 hour. So if you're doing any heavy-duty experiment that takes 1 day to crunch, forget about it. Right? It's not going to work on the free version. Next thing, your data, inclusive of the data that you upload and whatever other storage space needed for your modules, must fit within 10 gigabytes. Right? That's the upper bound. And right, some other constraints here. Okay, it will give an API, but it's not a production level API. Right? So there's no SLA involved. It may break, probably will break once the load is too high. And it will only operate on a single node, right? So you're running on a single instance on your platform. So if you're again running something intensive, the free one is not really for you. Okay, so for my researcher friends, for my colleagues, we're thinking about going down this road. As I mentioned, perhaps you can consider parking this under services or rental, right? And this is what it might cost you. Okay, you can't see any of this, right? But for the standard account, I've done some costing for you. All right. So if you want, they'll charge you a monthly access fee. So over 2 years, it costs you 1,000 ringgit. Not too much, right? Still within our, not on our normal budget, still right. Now, if you, yeah, 108, not for 2 years.
For 2 years, but each month you pay 1,080.
No. You pay for 2 years 1,080 ringgit.
It is written monthly.
Yeah. Oh, sorry. Okay, that's my mistake. Right. Thank you very much for spotting that. Right, it's not intentional.
My welfare.
Yeah, my welfare. Okay, I will listen. Okay. Right.
That is okay. It's monthly 1,080.
1,000 for 2 years.
Yes, you're right, Timothy. 1,000.
That's okay. That's not bad.
Now, assuming that you need your GRA to work on this platform, 8 hours working per day on a 5-day working week, you set you back about 16,000 plus. But we know our GRA don't work 8 hours per day, right? So you can scale it accordingly. Then, let's say you want to buy computation time. So 1 month worth of computation time. Remember, you're given only 1 hour, right? For the free one. Standard one, you calculate for about 1 month. It costs you about 7,000. So you agak-agak lah, go and plan yourself lah. Does my project need 1 month worth of crunching time? And to help you come to an answer to that question, you can look at the demo. The demo is quite small, 14 to 20 megabytes of data, crunching through 3 classifiers, putting it together about 2 minutes. 2 minutes. Okay, and then going to deploy for real, right? Let's say you want to show good people from MOSTI or MOTI or whatever not, right? This is really an upper bound. 200,000 times you call this API in a production setting.
So, Peter, just to interrupt, sorry.
Yeah, sure. No.
If I get a monthly subscription,
yeah,
there's still limited API calls. If I want to get 200,000, I have to pay extra for that.
Yes.
Oh, okay.
So using my ballpark figure here, it will cost you about 26K, but you can scale all this down, right? And
use, right?
yes, as on a per use basis. Yes. You don't use it, you have to spend the money. Okay, so
monthly fee is fixed.
Huh?
But we pay a monthly, that's fixed like that one.
Yes, that's fixed. That's the access thing. Yeah. So knowing how our grant system works, I would suggest that you employ this not as your main platform. Right? But if you want to do your demo, if you want to do rapid prototyping, this might be an additional resource. Yeah, as an additional resource on the cloud. Right? So a lot of times, I don't know about you guys, but when it comes to rental and all that, I'm not very creative in imagining things to rent. So, and services as well. So this might be a place to max out the services and rental. All right, so that your quantum goes bigger. Right? And
Sorry
people
for
sometimes
interruption. I have one doubt.
Yes.
While filling the grants, actually I filled for many grants.
Oh, really? I never feel for me. Okay,
Not
never mind.
for me.
I aside.
Not for me, but my prof.
Yeah.
In that, suppose the total amount we are requesting for is 1 lakh per year. So there are some percentage we can allocate for this devices, buying the devices and services, and the students those who are going to this.
Yeah, right.
So this will come under service, right?
Service or rental, I think. Yes.
Rental, okay. That will be only 13%, 3 to 13%.
1, 3.
Ah.
Okay, 13% out of, I don't know, 100,000 project would be what? 13,000.
We can't. The percentage of each thing should be equally shared. But if you are buying this service and we are not purchasing the system, then the share will be ultimately reduced.
Oh, okay. Then you need to min-max the whole thing and optimize it.
Yes.
I would suggest that at this point of time, you just tap on it as an additional resource. I don't know what you guys spend on rental, actually, besides going for research, writing retreats and all that. Yeah, but this is perhaps one other way of using it. All right, so Ian was telling me there's a MS, there's a Android Studio, right? So not everything is, not everything Untitled Studio is related to Microsoft. But anyway, here, this is what it does. It's a repetition of what I mentioned. I think what is important in this slide deck is that it's drag and drop. Now, why is this important to us? Drag and drop means that potentially you can use this and educate people who are subject matter experts or who can't code or have forgotten to code or wants to start learning how to do machine learning, and they'll be able to do machine learning very, very quickly. The learning curve is made much less steep. Yes, is very much flattened. Yeah. And you drag and drop what? Data sets, modules, right, into a canvas, and then you form an experiment, which you then run in your studio. Okay, and then you can edit the experiment, save it, change the parameters and all that. Then, once that is done, you convert it into something known as a predictive experiment, right? This is like the middle point, the staging point between your actual experiment and it going live, in a sense, predictive experiment, right? And then finally, it should really end here. You publish it as a web service, right? So you close the loop. You perform the experiment, get it to work, do your scoring, and happy with results. Then you publish it as a web service, and then you can integrate that into your own solution, right? Or I don't know, when Etiquette was around in TMR, he was pressing for things like web services and APIs and all that as an end result of our research plan, which I think will become more and more common. Right? No longer are we given the luxury of just doing research for the sake of research, and then there's no way of using research without complicated tinkering around it. Okay, you can't see a thing here. Never mind. I'm going to share my link later on. Many of you are on my social media website anyway, right? What you can do later is go over to the Data Science Institute Facebook page. We'll bit.ly there. Yeah. Thank you for the reminder, and we'll put the slides there, right?
It's already there.
It's already there. Oh, thank you very much. It's already there. All right. So you find a whole bunch of different techniques there that will cater for all sorts of things, right? Those of you doing classification, plenty of tools there, right? I think there's some deep stuff going on here as well. What the classifier is supposedly a deep neural network or not, but I've not played with that yet. And regression, clustering, etc. and so forth. Right? So this is a whole stack of stuff you can do. You can do a lot of visualization, right? Your scatter plot, your histogram, your ROC, right? You want to measure for that. And for training, there's cross validation, all the normal stuff they do in the course of a data mining kind of project. All right. And what else? What's the data sources that you can take in? Because it's a cloud platform, right? They do allow you to upload data, but they're very happy if you store it on their own cloud storage as well. Yeah, so it works both ways. And format, for my WEKA using friends, it will take in ARF files, ARFF. Yeah, it will also output as ARFF. Yeah. So if you want to compare, for example, what is output between one family of classifiers that is on Azure and the results that you're going to get if you run it offline on WEKA, you could do that. Yeah. Okay, data preparation, all the stuff that you can normally do can be done, right? Filtering, right? Filling in empty values, normalization, so on and so forth. All right. So it's a full, or as full as they are trying to get it to be, full predictive learning kind of offering on this particular platform. Okay. So this is the high level diagram on how this all works. Right. So this is the workflow. Right. Data goes in, reprocessed, you do the analysis, data reduction, extract the features, enrich it or reduce it as you like, test, accurate, train, then you score. When they use the word score, they are trying to get a performance measure out of your work. Right? So things like accuracy, whatever. Right? What does it take? You can take block tables, right? So it can work with Hive, right? Big data, right? SQL, Azure tables, or you have your traditional flat files, right? Or data, CSV, TSV, ARF, right? So it's happy to play with both structured and semi-structured data. Right? Outcome will be in the form of squad data. All right. You can also save your models, experiments until you can save it as a model, and all of it lives in the cloud.
Doesn't write paper for you.
Sorry.
Doesn't automatically generate paper.
No. That one is something beyond it. I'm quite glad. Because it means if you can't write paper for me, I'll drop.
He's not fine enough.
This is the IDE. It's very blurred here, right? But when you guys go and try it for yourself, you can go through it one by one. I'm going to go through it one by one on the demo. But it's still going to be blurred, but you see closer, I'll try and make it as clear as I can. Okay, what are components? You have at least one data set, one module, right? Data set will be connected to the modules, right? In this sense, it's very similar to your experimenter. Yeah, those of you who have played WEKA experimenter or RAPIDMINER or KDIM, same thing, right? Data goes into a module and something happens to it, then output goes somewhere else, right? And yeah, so, and a lot of the modules can and must be set, right, in terms of your parameters. Okay, so this is one of the major stumbling blocks of AML, right? You're stuck to less than 10 gigabits of data. It can, gigabytes of data. It can handle this kind of data, sparse, categorical, string, binary. I've not seen any tutorials that took a picture and dumped it into Azure ML yet, but might work, might not work, probably would not work yet. And then, again, lots of restriction in terms of the modules, right? So once you go past 10 gig, Azure really isn't for you. Yeah. And for data sets bigger than a few gigabytes, in the FAQ, what they meant by a few is 2. Anything larger than 2 gigabytes, again, you should not be uploading up to Azure. You should be uploading it to something else and do the connection from there.
This 10 gigs only for the feature or 10 gig for the
whole chain bank. Yeah. Data plus your modules and all that.
But free, the free plan, right?
Mm-hmm.
So the free plan, right? Is it?
Yes.
Not a paid version.
Oh no, paid one, of course it goes up. You're paying one. So the restrictions are, it's a bit more unshackled. Yeah, but I didn't go into the standard plan, the parameters for it, so my focus was on the free plan. What is a module? Module, to cut a very long story short, is an algorithm, right? You can run 4 modules in parallel. It's really good if you want to compare the performance of different kind of classifiers. So you can run it together, and you don't have to run one at a go. And right, this is some of the things that they support. Right, Bayesian, right, you'll be happy. Right? Deep neural network, I have no idea what it meant. Then they have something called decision jungle, right? Your decision tree, right? Then you have forest, and now they have a jungle. What comes after jungle? I have maybe this decision Amazon, right? From Amazon. Okay, whatever not. Also, WEKA Rabbit, right? Those of you who have looked at WEKA Rabbit, you find that it can process lots of data very, very quickly. Yeah, so if you're into that, you're dealing with big data, you might want to consider checking this out, right? Because AML is not the only way of getting access to WEKA Rabbit, right? You can get it elsewhere. There's even an R interface to it. Okay.
Before that, about the parallel. 4 modules executed in parallel, but we're still running on one node, right?
Yeah.
Using a free one.
Yeah. So your one experiment, you can run 4 classifier, regression, whatever not. You can do it at the same time, at the same level.
At the same time, but only on one node.
Yeah, only one node. Yes.
It's not parallel processing, it's just 4 modules running in parallel.
So in other words, right, I think you can run 4 machine learning tasks at the same time in a single experiment. Yeah.
But it doesn't know how to.
But I think the 4 have to be at the same time. I don't think you can run one classification, one regression, one clustering, and one. You might not, but then the results. I don't know how I'm going to integrate the results. I didn't play it too much. Yeah.
I understand. They should be. I think should be like the 4 classification.
Yeah, that's right. Yeah, so question.
Yeah.
All right. Okay, so for the demo, right, these are some statistics before I run it for real. Very small data, right, 14.25 megabytes only. Okay. Experiment size 0.03 gigabyte, so plenty of space. Runtime, someone asked me about performance. Not too bad, 2 minutes you can get this done. Right? And basically in this demo, right, basically we want to perform this, right? Action classification, and we want to detect whether the person is sitting, standing, walking, standing up, or sitting down. Not very complex actually, but still, it is action recognition. Right? So you have scored probability and class label. So they'll tell you for each probability what is the one that they use to decide on the class label. And this is published as a web service. And I'm going to show that this web service can be consumed easily in R. If you want to do it in Python, they provide the Python code as well. I did not try Python because I don't do snake language. So, yeah, it's just R.
What's the language?
Python R, right? Okay. So my personal impression. Okay, I think it's very good for people who don't code, right? Or are scared of coding or forgotten to code, right? But they are they are subject matter experts. You can teach them how to do this, right? And then they'll be able to rapidly prototype something out, right? This is where you come in and you try to do your data science, machine learning magic, and beat whatever they are able to do here, right? Learning curve is not difficult at all, right? If you are familiar with WEKA, RAPIDMINER, K-name, whatever not, you should be able to pick this up easily. Yeah. For the FYP students, if you're scared to death of machine learning, right? This is very gentle introduction to it, right? Expose to you the pipeline of how things are done. You don't code anything, and then from then on, of course, you jump off this platform and do it for real, right? On your favorite language. Okay. So on paper, right, the ability to integrate the experiment as a web service will be useful. However, for production usage, then if you choose to do it this way, you're tying your solution to ML. So that's one thing you need to remember. In terms of reproducible research, very repeatable. Once you have the module up, you share it with someone, you can repeat experiments as many times as you want. Right? If you have a kick-ass demo that you want to share with the public at large, you can also. Right? You can do your own stuff, share it out in the public gallery, right? All the magic bits to yourself. Right? And what are the drawbacks? Right? It's not a magic silver bullet. Basically, I think, in my opinion, what is the major drawback? Support for large databases is lacking, right? And to solve it, it means you need to spend more money. Right? So that is the problem here. Okay, opportunity. Right, this is targeted more for my colleagues. Right, if you need compute and storage resource, yeah. First of all, deadline August 15th. Right, I didn't spring something that is due next week. Yeah? August 15th, about a month away from now. You can ask for storage and compute resources, and it will cover the scope of things that will cover would be like things like Internet of Things, climate, public health, machine learning, data science, right? And yeah, you can apply that. And the size of the award is large, right? Not in monetary terms, right? In FAQ, they said if you ask them for 1 GB of storage and 20 hours of compute time, they will tell you go and fly kite, because you can do that easily on the free version. Now, what is typical? 20 tera worth of storage and 200,000 hours of compute time is reasonable. All right. So, if at any point in your project you need additional crunching time of your own infra, right? Try and convince them. The call for Azure grants is on a Monday basis, I think, or no, bi-Monday. Wait, no, it happens once every even month, right? So you miss the boat for August, you open up in October again. Yeah. So
there's no monetary run for this, right?
Sorry.
There's no monetary run.
It's just a compute resource. What I have done in the past, because I wanted it to count somewhere, I actually asked Microsoft to quantify this. So Microsoft came back with a figure to me. So in terms of reporting, making CK happy and all that. Okay, okay, I got this grant, it's worth this much. I got a letter from Microsoft, and it's up to him what he wants to do with it. Right? Whether it translates into your own KPI, I don't know. But still, if you win this grant, it's a nice line in your resume. Yeah, knowing Microsoft, you're not too particular about the end result. Back then, let's ask what sort of grants they would just give it to you. Right? Just the resources. Okay, yeah, someone asked me again, how does this compare versus Watson and all that? Right, there's a link there, you can click on it. Right, the algorithm cheat sheet is here. Right, some articles on Azure on heavy nuggets. Right, research grant, you find more information over here. Okay. So that ends my presentation, and now I'm going to do the demo. Because I think that might be a good idea to sit up front a bit more, right? Especially if your eyesight is concerned. Okay, super blur, but this is the machine learning studio, all right? This is the machine learning studio. And you can, of course, you have a project folder, right? So you can put all your experiments here, right? That little icon there, the bigger, that's the number of experiments you have, number of data sources, number of models that you have, and etc. and so forth. Then, if you click on experiments, this is where you have the blank space, right? This is where you have the blank space that is spinning up now. And I'm going to pick the baseline experiment. notice that I have a training experiment and a predictive experiment, right? This shows you that, well, I managed to deploy this thing as a web service already. Right? So you run, the idea is you run your experiment here as a training experiment. And then once you are ready, right, to deploy it as a web service, you then convert it into a predictive experiment, right? Okay. So this is the data set, right? If you want to refer to the paper, it's done by a bunch of resilient people, right? And see, next time, guys, if you have published a paper already and you've done it on Azure, put it on the gallery, right? Then people can see, oh, okay, right? Then maybe they'll remember you when they're doing their citation, right? So another way of getting some eyeballs on you. So for the data set, you can right-click. That's like everything Microsoft. You can right-click and you can do stuff with it. You can download. Right? I've done the download already, and this will allow you to look at the data on Excel. Right? Just to make sure that it's correct and all that. This is not the data. Right? Okay. You can also visualize here. Data set, visualize. If you want to do your exploratory data analysis, yeah, you can have that, right? Visualization. So you see that it has 19 columns and 165,000 actions. Right? Actions, yes, yeah. So it's, and then you get the normal demographic kind of data. Yeah, and then you get all the accelerator readings. Okay, 3 axes, right? And so it's off. Okay, and you can do your visualization here. Okay, so it will come out as histogram and all that. Yeah, how tall the people are, how heavy they are. And so on and so forth, right? So the spread of data is shown. Okay, now for the rest are probably, this is probably not new to you, but for those guys with FYP and want to do the machine learning, right? One of the things that we need to do is to clean up the missing data. So there's a module from that, right? And you will find that under here, data transform. All right, data transform. Right, somewhere here. There we go. Right, so just click here, right, and then you drag it over, right, like so. Right, then you then link it to your data set. I'm not going to do that now. Okay, and then next up will be a selection of the columns. Right. Now, again, for those of you doing FYP, not every column in your data set is useful. Right, so here, all the user data and BMI and all that is taken out. All right, and then you can edit the metadata, change the data class to the data type, the type that you want, and then you do the training and testing split here, split data, and then after that's all done, after the data has been split, you can then run your models. Okay, so over here we have 3 models. Multi-class decision forest. I think you're saying you try with binary classes only. They can handle multiple classes. Right, so multi-class neural network and multiple decision jungle. That's the fancy name for, I guess, one of the random forest implementation. Okay, where are the algorithms? Okay. Here is where the algorithms are. Right, it's under okay. There. A lot of you are doing classification here. So under algorithm machine learning, initialized model, classification, then you have all these things. Right? Okay, you can do clustering and regression as well. Okay, so regression is when you want to predict a value. But I think none of you are working on anything that's related to that. So use that. So once you have done the model, right? This thing, right? You're going to train the model, right? Training the model so that it picks up on the representation of the data, signs of the classes. Then you're going to score the model, right? And then scoring is really where you get all the various parameters for the performance of your classifier. And then you select the data set that you are interested in, the columns in the data set, and you put it together. All right, you combine it, rename it, run the R script. Okay. R script you can't really see, but you get a snippet of the R script over here. So basically, it is just to rename some of the columns, right? And then restructure it, and then define where is the output port and all that. And finally, you have the CSV that I showed you just now. All right, this is the overall precision for every instance in the experiment. Okay, now before you can publish this as a web service, right, you need to do this. Click on your model, all right, and you save it as a trained model, right? So this is the thing that you need to do before you can publish it as a web service. So I've done that already, right? And then after everything is done, you just need to press run. Right, 2 minutes will be done, unless I click something and cause it to break. I don't think I did. And for the modules, of course, once you right-click, you can set your parameters, right? For example, for the training and testing split, if you don't want it to be 70-30, you can split it to 80-20, 90-10, as you like. Okay, so it's done. Right, it's done. And how do we know it's done? You can do this. All right, that is the result. Results data set. Okay. And you can save it as Python notebook, for example. Again, it lives on the cloud. Any problem? Not my problem. It's not generalized. Okay, so it will give you the code for doing all this. Yeah, from Azure, and then right. This is your key and all that. All right, and yeah, that's what's going on over here. Okay, then you have set up web service. So here, right, what you can do is you need to pick on one of the model. Right, pick on one of the model, and then you set up the web service. Right, deploy the web service. And what you do is then you launch this window here, which is the predictive experiment. And if you look at this, right, what it does is that it focuses the web service in such a way that it will focus on a particular model. Right, in this case, I'm using a neural network model, and it will output the result over here. Okay. Now, let's go over to the web service. So you see that I've got 2 of my web services set up already. So I'm going to click the predictive experiment. That's the one that is published and consumed by your favorite programming language. All right. So you don't want to do that yet. You can do this. Click on this. Yes. it's going to spin up something here. Okay, so it plays very nicely with Microsoft Excel for obvious reasons. Okay, so there you have it. Okay, so this is the prediction for sample data. So the first couple of lines there, right? Then you're free to play around with the parameters, and then you can redo your prediction. Yeah, redo your prediction. So this is a snapshot of what is being offered by the web services result. Yeah. If I go back here, then you can. It also does batch execution, which I didn't play with, right? You can look into that yourself. This is the API documentation. Alright, so there you go. There's your JSON input. Right, so it's all the columns that you have within your data set. Right, so publish there. Okay, this is your JSON reply. And for those of you who are absolutely phobic into programming, right, they're kind enough to give you the sample code to consume this. Right? It goes into C#, goes into Snake language, goes into R. Right? And I'll just show you that this actually works. I was working at about 2 o'clock this afternoon. All you need to remember is to change the API key, right? Paste it into your code.
Nice.
Okay, and you get the end result over here. Yeah, so it's coming up. I think the neural network has got it wrong. Not all the values are 0, and yet it says that this person is coming up. I don't know why. Anyway. Yeah. So the integration in R, but you can easily integrate into C#. Once it's in C#, you can port it into your standalone application or into your favorite ASP.NET language. So there you go. It's an end-to-end presentation, right, of action recognition based on sensor data using drag and drop. And I think what it does for us that we could not do with WEKA and all that is it gives you a very nice web service which you can then expose to people and integrate it into other kind of things. All right. Are there any questions? No? Okay. All you need is a Microsoft account and you can play with this. Okay, I'll pass the time over to my mom.
Okay, so thank you for coming. So today is actually quite a large crowd. Just to tell that we are actually having this knowledge sharing weekly basis. Okay, so it's actually we have a website very easy to remember. You can see now that all our talks are recorded. So we actually aim to encourage that knowledge sharing. So bit.ly/. Surely it is not working. DSR lab.
Yes. Research lab.
DSR.
Sorry, I don't know you in photography, you get it wrong.
Seminar. Okay, so you can see that all our talks are recorded, and then all our code, whatever that we demo, I think previously I gave a talk on Python. I think some of you know. So all the code is there. Then every single time where our presentation, we try to pipeline it. We actually record it, and it's actually available in YouTube. Okay. So I hope that we want to actually encourage people to come in, do some knowledge sharing, and we try to do it in 1 hour, so we won't waste your time. But it's just like you go and attend a nice conference and you just want to sit there and just listen something, get something knowledge. We don't want to have a 2 hour long session. We just everything is So the next one will be one of the students, master student, he will present something on Twitter road prediction, road traffic prediction using Twitter. He'll talk about that. Hopefully he's ready. And beside that, I'll be, since I started with data wrangling or data pre-processing with Python, in the part 9, I'll be talking about pandas, how to manipulate data with pandas, Python. And the end goal is I want to talk about how to do machine learning with Python, scikit-learn. Okay, so you can see if you go to all, for example, my one is all code. You can actually go and try out code there. Some is just a paper, refer to a paper. Some postgraduate students they will actually do. These are all my Python notebook code. Some are actually papers because the students that they actually doing postgraduate, they actually do a review of papers. Some will do the slide, but so if you think that you want to know, I have studied something, I think I want to share it. It doesn't matter whether you are a postgraduate student or you are actually an undergraduate student, we welcome you. Because there was once you pipeline you, they put you in the pipeline. We always encourage the people to watch. Okay. And this effort, what we are doing now is actually part of our bigger effort. We are actually in the Data Science Institute. So we have a group of people from all across faculties, engineering, we also people from FOM, management, FCI, people from London. So we are trying to group all people from all sorts of areas to come together and tackle the big data problems. So if you know that big data problem is just not computer problem, it can be financial problem, it can be image recognition problem, it's all that. Okay. Okay, so today Peter is very popular because there's so many live videos, so many photos. Okay. So we have a Facebook page also. At the moment, because our Data Science Institute is not approved by the Senate, so we don't have an official MU web page, but we have a Facebook page. So you can actually get our updates, our presentation, all our things in just now that website and also Facebook page. Okay. So if you are any friend who would like to come, please do come join us. Now I have my 3 out of 4 FIB students here today. I need force them to come.
Just keep hinting to them. Right?
Okay, so that's it. Just a short